What's up, Joe Gamers? Why am I saying right? Joe Gamers. Today we will be talking extension to what we're talking about, planes. I started talking about planes, not the 9/11 planes, but planes in general. So I want to continue talk about planes, and more specifically, hold on, this music a little too loud. So, more specifically, I want to talk about two planes. Two planes. Let's see if I can have grid paper. Grid paper. Like that. Nah. No, this is fine. Yep. Okay, so I'm gonna talk about how do I make switch background? There you go. All right. We're gonna talk about two planes. This is kind of hard to write in. See if this works. Yeah. Alright. Anyways, crap. So, let's suppose you have, Suppose you had a plane like this. Okay, and then, like I said in the other video, you can define the plane with a point anywhere on the plane and a right angled vector of the on the plane. Another and then say you had another plane. Let's say this plane intersects like this. And its angle, or its vector, its right angle vector is like that. And we can see in the intersection, kind of bad drawing this, but it's like around here. This is the angle, right? Angle theta. Well, this angle theta can actually be given by the right angle here. So let's see. So it's in this direction, so I just gotta move it here. Like that. Say this angle is the same as this vector is the same. We just translated it to where the other right angle is. And then this is the same angle as the angle of the intersection right here. Alright. So that if you can find the angle between here, you can get the angle of the intersection. And how you find the angle here, if you remember the dot product. So let's call this N1 let's call this 1, let's call this 2. And then we do the dot product of N2. Well, that's gonna equal the magnitude N2 times cosine theta, which is also equal to the components. So let's call A1 times A2 plus B1 times B2, and then if it's a C, then you do the same thing. Anyways, so you can find the angle using this. Just solve for theta, and you get the
gynecological care. The
you get this theta
is with you for each step, from symptoms
equals
to solutions. Our specialists provide expert attention to your needs with compassion and clinical excellence. From routine exams to
blah blah blah.
complex
I'm not writing that
conditions.
again.
Our team's complete
N
obstetric care is here with you, from preconception to postpartum visits. Schedule your women's health consultation
And
today
yeah, that's
at
how you find the angle between intersection. But
collegehealth.org/OBGYN.
you know what? I think I'd care more about the line of intersection. So the line of intersection, this kind of looks a bit janky, but let's say, let me draw a better plane intersection, like, hold on, like this, and then we got a plane like this.
Where do you go for fantastic hair? At MS Cut and Color, we do haircuts, color, treatments, and more. Whether you're looking for a
So
bold
our
new
line
hue or a fresh trim,
would be
our
like
expert stylists deliver
along
hand-turning results
here,
at prices you'll love. Visit your
and
Southern
they're trying to
California Fantastic
find
Sam's salon
what this
today.
line is. Now, to find this line of intersection, we have to actually know that since this line intersection lies on both of these planes at once, that means its parallel vector is actually both perpendicular to this plane and this plane, the two planes. And to get the vector, if they're both perpendicular, is times n1 cross n2 in order to get the parallel vector v. That is parallel to this, and just get one point. If you just solve for the intersection, find the point in the intersection, then you can probably find a point so you can make the line with V and that point, right? So let's see how much time I got left. Alright, let's try to do a practice problem. Let me just set it up real quick. Alright, I'm back. Set it up right here. It's gonna be a double problem. We have to find the line of intersection, and then we have to find the point that contains the line of intersection.
But I can lock it on my phone.
Yeah.
Okay, so what now?
And we're not gonna try to find the angle
and get a new one printed
of
instantly.
Sounds like
function,
BMO are the real
'cause,
magicians.
Well, yeah, when you put it like that.
kind
Accounts are
of
subject to
pointless.
approval and are provided in the
That's
United
pretty
States by
easy.
BMO Bank and A. Member FDIC.
So, not really a point in
Entertain
doing
effortlessly
that.
this season by serving perfectly mixed cocktails from Cutwater.
Anyways,
Cutwater, real cocktails,
let's do
perfectly
this.
mixed. Copyright 2025, Cutwater
Alright.
Spirits, San Diego, California. Enjoy responsibly.
Yeah, well, okay. So these are the plane equations that I've showed how to get to that equation last video. And we have to find a plane that passes through the line of intersection of these planes. So where do we start? Well, let's start with finding the line of intersection, right? So the line of intersection just requires the vector, like I said, a vector. We have to find the vector. So the vector would just be, like I said earlier, these two perpendicular vectors cross product. So this one's n vector would be 1, 2, 3. And the other one cross product is 2. Negative 1, 1. And this I, J, K, 1, 2, 3. 2, negative 1, 1. I don't know if I gave you guys an example of how to do the cross product, but whatever. So, first slot. Alright, so we cross these out and go left to right. So that's 2 minus negative 1 minus 1 times 3 is 3. So that's 2 plus 3, and that's 5. So and then next is J. So we do that. Left to right. 1 times 2 is 6. But remember, it's negative, so it's 1 minus 6 times negative. So, yeah, okay, so the result obviously will be negative 5 times negative 1, which would be 5. Next, K. Okay. 1 times negative 1 is negative 1. 2 times 2 is 4, so negative 1 minus 4 is negative 5. Alright, that's our perpendicular vector now. Alright. So, if we were just getting the line of intersection for this problem, what we'd have to do is find a point where the line intersects. And I can do that. I can show you how to get a line that intersects, the point where the line intersects, or the plane intersects each other. Alright. So, imagine a plane. Why the funk stop? Never mind. Oh, it's that. Alright, imagine a plane. Z, X, Y. So if we had a plane, just a regular plane, say it's going this way. And then we had a, actually I just do it in a different color. We had another plane that does this. So where I'm getting at is that if you can see, these planes are infinitely going that way and that way, by the way. Alright, for the red, goes that way and up. So that must mean that there is some point within this intersection where a number can be any number, or a variable can be any number. What I mean by this is, let's get an example of Z. So this line of intersection, you can just draw the green. It's infinitely long. So at some point in the line, since this should be a continuous line, so the mean value theorem between infinity and infinity, or negative infinity, negative infinity, negative infinity, you get the point. There should be at least one point where Z should be in the middle of those two, and 0 is in the middle. So say the line Z equals 0 is somewhere, well, I didn't draw a good line, but it's gonna be 0 at some point, right? So because it is 0 at some point of the intersection, that must mean those two planes intersect at 0. Or it could be Y, because look, in the Y they don't have to hit the origin, but at some point Y is 0, or at least Z is 0, or X could be 0 around here. If we had like an actual graph of this, it'd be more better to visualize. But what I'm trying to say is you can set a variable to any number you want, any z, x, and y. For any variable, you can set it to any number, but only one of the variables, and you'll get somewhere. You get a point somewhere that lies on the intersection. And how we can solve for that is setting them equal. So for sake of simplicity, I'll set z equals 0. So now the equation would be x plus 2y equals 1, and then there's 2x minus y, right, equals negative 3. So now that we have z equals 0, and we can draw this as a line like this. So then if we draw it as like a plane z equals 0, right, and then it would extend to the x and y, or no, if z equals 0, it would look like this. It would literally look like the x and y plane, right? And if we rotated our camera to look directly at the x and y plane, you'd only see z equals 0, so this is z, and say that's 0, right? We're just drawing it really small just to show a point, and this is y and x. This is the same line of intersection, two planes, right? So blue would look like x plus 2y, which is y equals 1 minus x over 2. So you'd see a line going, I don't know how to draw this. Probably like this, right? And then you'd see the red line, which is this. I think, okay, it's 2x plus 3. So you probably just see something like this. This is from the top view of this one green line, alright? Or not the one green line, but from the top view, it should look something like this. I might go on Desmos to show my point. Go on Desmos. Alright, now that we're on Desmos, you can see the color thingy on here. So if you look, so this is what it looks like from how I drew it earlier, the x and y view. So this is what the planes look like, and this is what the lines look like. And look at here, this is the intersection line right here, right? And if we look at the top view, we see that they intersect at z equals 0, and we can see those two equations. We just cancel them out, and you can see how they align with each other, right? So this is what it would look like, what it would look like from the top view,
Zero
right?
Shoes. Each pair of Zero Shoes is designed to give you the real freedom that comes from natural movement, bending, flexing,
if you
feeling.
just
No
do z
pinching,
equals
no
0
constriction,
and
just
z
pure
equals
free
0,
movement, pure relief. And walk
you'd
all you
literally
want, because
get
every pair of Zero
the lines,
Shoes
I
comes
think.
with a 5,000-mile sole warranty. Let your feet do what they're supposed to do. Learn more at zeroshoes.com. That's XERO shoes.com.
There you go. Yeah. See how these lines just turn into exactly the lines I just wrote down.
I can connect with the
So at
trees
some
and the
point,
spirits
there'll be
of
z
the
equals
wind
0,
and the
or
sky
maybe
and the land, but
there'll be
I
z
feel the
equals
most connected
1.
with animals.
And see
They're
the
our
line of
teachers, our
intersection.
furry, fuzzy, scaly
Z
Buddhas, if you
equals
will.
1.
Want a career as a pet psychic? We're
And if
not
we
the school
check
for you.
the
Want a degree to help
intersection
prepare you for a
points,
career in healthcare, business, or education?
this
Check
line
us
of
out at
intersection, we can see this
post.edu.
line.
Post University. Post
That will
makes
be
it personal.
any ZX, ZY
Whether it's a
value,
drive,
as
drop-off,
long
Slack,
as
or
you
that
don't
folder
make
called
two
Ugh.
pairs the same
Dropbox
number,
Dash finds
you'll
it
for
fast.
sure at least
Smart
get
search.
a value within
Built
the
for
line.
messy humans.
Alright?
Learn more at
So, yeah.
Dropbox.com/.
Disney California Adventure
Alright,
Park.
now
You
we're back
remember the
to
music,
whatever.
the food, but most of all, the time spent together as a family.
So
August 22nd through November 2nd. Visit
so
Disneyland.com
y
for details.
equals 1 minus 2x, right? I don't know. And then y is also equal to 3 plus x. And if we solve these two equations, we would get x equals 4. I'm gonna skip that part, but just know it's x equals 4. And if you plug in 4 for here, you get, wait, hold on, no, you don't get 4, you get 1. Negative 1. And if you plug in negative 1, you get y equals 1. And we already set z equals 0. So, point on the line of intersection is 1, negative 1, 0, I mean, oh crap, 1, 0. And why this is important is because we just got the vector v and we're looking for the plane that contains this line, right? So, we see this. Okay, look. We got the vector v, so it should be something parallel to this line, right? And we just got a point on the line, let's say it's right here. And we also have a point on the other plane, which is 314, which is the plane we need to find. Say that point is right here. Where did I draw the vector? I don't know where I draw the vector, but wait, no, the vector's right here. So what I'm gonna do is I'm gonna show you that I'm gonna make a vector between the points we just found. So then when I translate this point here to the parallel vector, we can get we can do the cross product between the two and get a right vector angle such that we can get the right angle and we know the point 314 to make the plane. So with this we can find the point. So this is called P, let's call it P1. So P1 PO vector. The vector is equal to the distance between them. So negative 1, 314. So I'll make it go from I'll make x2 PO and x1, I mean x1 P1. So then this would be 3 minus 1, which is 4. 1 minus 1, 0. 4 minus 0 is 4, so it's 4, 0, 4. Like that. And we'll do the cross product of 404 with V55 negative 5. And we'll get I, J, K, 5, 5, negative 5, 4, 0, 4. And same procedure. I'm gonna ignore that part and just do 20 times 0, so that's just 20. And then for J, it's negative, so 5 times 4 is 20. 5, negative 5, so that's 40, but it's negative 40 because J is negative. Or is it? Alright, yeah. And then, okay, and then the last one for K, 5 times 0 is 0. 5 times 4 is 20, but it's the last one, so it's negative. So that's the right angle vector for the plane. And so just put it in 20x plus minus 40y minus 20z equal to D, negative D, but D is negative times these coefficients times the 314 we just had, so cancel that negative, and we just have 20 times 3 plus, or actually minus 40 times 1 and 4 and minus 20 times 4. And we get the answer of, oh my god, I think it's 60, yeah? This is 60, and this is 20 times negative 20, what am I doing? That's 60 minus 40 minus 60, wait no, 20 times 4 is 80. So yeah, it is negative 60. And then we can divide negative 20, we can divide 20 on both sides and we get x minus 2y minus z, and then add the 60, now it's 3 plus 3 equals plus 3 equals 0. That's the answer, yay.